Mathematics is made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Target online class. Today we want to look at definite integral. Definite integral. So if you have the integral AB f of x dx. So in this case now, where a is the lower limit, b is the upper limit. That simply means that this integral has a bound from a to b. Is different from the normal integral that we normally have, that is open-ended. Under indefinite integral, it is open-ended, so no bound. So under definite integral, I said it is compulsory to put arbitrary constants whenever we integrate. But under this definite integral, it is not compulsory to put arbitrary constant, because once you put arbitrary constant, you see the implication. There will be cancellation. The two integral will cancel out, because we are this upper and lower limit. That is, if you integrate this, if you integrate f of x ds, by the time we integrate this, we are going to have f of x plus arbitrary constant. That's what we are going to have when we integrate this. Then we indicate the lower and upper bound. Then the implication of this is that we substitute for x at the upper when x is equal to b, f of b plus c minus, we come back and substitute for when x is equal to a, f of a plus c. So if you open up, we are going to have f of b plus c. This minus outside here, we control everything inside the bracket. Be minus f of a minus c. C we cancel minus c. At the end of the day, the final answer will be f of b minus f of a. Now, this is the reason why I said that when you have definite integral that has bound, upper and lower bound, you don't need to put arbitrary constant, because along the process, the arbitrary constant will cancel out. So it's going to cancel out, and that is the reason why I said you don't need to put arbitrary constant. Now let's see something there. So let's note that if you have integral f of x ds ranging from a to b, it can be written as integral a to c f of x dx plus integral c to b f of x dx. That is, what we are trying to say here is that you can actually split it. When you have this type of integral, it can be splitted, so that you decide to split it. There is something in between from a to c. Now then, plus from now c to a, it's still the same thing as you moving from a to b directly. You are still going to get the same thing. Then another point you should know is that when you have integral ab f of x dx, the same thing as minus integral, where we now interchange, when we bring a to the upper and b to the lower, ab f of x dx. Please, let's take note of this. So we should take note of this. So we'll now go ahead and give two examples under definite integral. Then we call it a day. So let's see example one. We have to find the integration. We have to integrate. So maybe evaluate a integral from 0 to 1 dx. Then let's take another question where we have integral from 2 to 6, 3 all over s squared dx. Then let's take one more in this first example where we have integral from 1 to 2, 3s squared plus 4 dx. So let's quickly do the three questions that we have on the board. So how do we integrate this? We start with the first one, a, integral 0 to 1 dx. When you integrate dx, we are going to have x. Then here will be equal to x into bracket 0, 1. That's what we are going to have. You know, normally when you integrate dx, you should have x plus c. But since we know that under definite integral that has bound, there will be cancellation. That's why we don't put an arbitrary constant. Then the implication of this is that you substitute for x when x equal to 1 minus when x equal to 0, and the answer is 1. We go ahead and check for the second one. Integral from 2 to 6, 3 all over s squared dx. So that's the second one. So how do we integrate that second question? That is what I'm about to do now. That second one, of course, the denominator we have s squared. You can try to bring it to the numerator. You can try to bring it to the numerator. It's allowed. That is, this is what I'm trying to say. That you say integral from 2 to 6. You cannot say this is 3 x minus s raised power minus 2 dx. That is law of indices. If you want to bring the reciprocal up, it attracts a negative sign. Okay. Then from here, I can bring out 3 to have integral 2 to 6, then x minus 2 dx. So under integration of polynomial, what do you do there? This is 3. You know, we are going to have plus 1. And what we have as the power is what we have at the denominator. So we have x into minus 2 plus 1. That's minus 1. We have s raised by minus 1 all over minus 1. That's what we are going to get. No, when we integrate this, once we integrate, there won't be integral sign again. We have 3 multiplied by s raised by minus 1 all over minus 1, 2 to 6. Okay. And if you write that correctly, we are going to have minus 3, because this minus will take care of this, minus 3x raised to minus 3x raised to power minus 1. Okay, or I can write it from here and say this is minus 3 over x, everything 2, 6. Then we substitute for when x equal to, we substitute when x equal to minus, when x equal to 6 minus when x equal to 2. That is, we are going to have minus 3 all over 6. That's the first one. When x equal to minus 6 minus 3 all over 2. That's minus into bracket minus 3 all over 2. So if you look at that, what do we get? We had this. I'm going to have minus 3 all over 6. Minus will be plus 3 all over 2. And if you find the LCM of this is 6, I'm going to have minus 3. 2 here is 3. Plus 2 here is 3. That will be plus 6. Plus 9. That's what I'm going to have. Plus 9. So from there, I will have 9 minus 3. That's 6 all over 6. And the answer will be 1. So the answer is going to be 1. So we are going to get 1 as our answer there. Then we can go ahead and solve the third question. Here we have, and the third question is, this is the third question, where we have integral from 1 to 2, 3x squared plus 4 dx. So if you want to do this, just go, we are going to integrate this directly. Okay, that is where we have, if we integrate this, we are going to have 3x cubed 1 over 3 plus 4x integral 1 to 2. That's what we are going to have. Then we substitute when x equal to 2 minus when x equal to 1. So we have, so that we have 3 into bracket 2 raised power 3 over 3 plus 4 multiplied by 2 minus, we substitute when x equal to 1, 3 raised power 3 into 1 raised power 3 over 3 plus 4 multiplied by 1. That's what we have. Then here I'm going to have 3, we cancel 3. At the end of the day, I'm going to have 2 in 3 places. That is 8 plus 4 times 2, 8 minus into this bracket. This will cancel this. I'm going to have 1 plus 4. So this is 16 minus 5. And the answer will be 11. So if you do that correctly, we are expected to get 11 as the answer. So that is what we are expected to get. So we go to the second example. So I'm going to take the second example. Let's take the second example. Say example 2, where we have integrate. So we have to integrate or evaluate. The first one, integral from minus 1 to 1, 2x plus 1 all square dx. Then B, the second part of the question, we have integral from 0 to pi over 4 x sine x dx. So let's look at the two examples there. Let's look at the two examples that we have there. Let's look at the two examples there. So what do we do here? Look at the two examples. We start from the first one. When you are asked to evaluate or to integrate what you have there. So once you have definite integral, you don't need to put arbitrary constant. We have established that. Solution. Let's look at this first one. We have integral minus 1 to 1, 2x. So in this case now, it depends. You can decide to use integration by substitution to first integrate what you have on the board, or you just open up. That is, you have 2x plus 1, multiplying 2x plus 1. It is square. So if I open up, I'm going to have 4x squared plus 2x plus 2x plus 1. So that at the end of the day, instead of what I have there, I'm going to have 4x squared plus 4x plus 1, everything dx. Or I can go ahead and use integration by substitution. We are still going to get the same thing. So when I integrate this now, I'm going to have 4. This is squared plus 1. That will be 4x cubed all over 3. Plus, here we have 4x squared all over 2. This plus 1. Then plus x. Everything minus 1, 1. That's what I'm going to have. And at the end of the day, this will be 4x cubed all over 3 plus 2x squared. Because 2 we cancel this to 2. Then plus x minus 1 to 1. We go ahead here at this point to substitute. So when x equal to 1, I'm going to have 4. 1 in 3 places, that's 4 over 3. Plus, this is 2 plus 1. Minus, when x equal to minus 1, I'm going to have minus 4 over 3. This here I will have plus 2 minus 1. That's what I'm going to get. That's what I'm going to get. Then we can try to add everything together. This is 3. This will give us 3 whole number. Here will give us 3 whole number. We're going to have 3 whole number 4 over 3. So 3 whole number 4 all over 3. 3 times 3. No, 3 whole number. So let me just find the LCM so that I won't stress myself. 2 plus 1 is 3. So if I find the LCM here, the LCM is 3. 4 plus 3 and 3, that's 4 plus 9. Minus the one we have here. 2 minus 1 is 1. So here I'm going to have 3. Then minus 4 plus 3. That's what I'm going to get. So at the end of the day, I will have 13 all over 3 minus what do we have here? Minus 1 all over 3. So if you open up, you are going to have 13 all over 3 plus 1 all over 3. And that gives us 3. 13 plus 1. So we are going to have 14 all over 3 as the final answer, which is 4 number 2 over 3. So that will be the answer. The answer will be 4 number 2 over 3 there. That is what we are going to get. But the second question now, is integral of the product of two functions. X is the polynomial function, y sine x is trigonometric function. So when we have product of two functions, most of the time we use integration by parts. So you can check what we have done in the past. Check my videos on integration by parts. So how do we integrate that? Before we substitute, the only difference between definite and indefinite integral is that you first do your integration, the normal integration. You won't put arbitrary constant, then you now do the substitution. So in this case now, if you want to use integration by parts, by formula, integration by parts by formula is integral v du. Integral v du is equal to uv minus integral u dv. That is this question that we have now. We can call this one v. We call this one du, so that we know the value of dv and u. So here u is equal to x, and the u, integral of the u is equal to integral of sine x dx. So if I differentiate u, the u, I'm going to get dx. That's what I'm going to get. Then if I integrate the u, integration of sine is minus cos. That is, here I'm going to have du is equal to dx. Then integration of this u is going to give me sine is minus cos. So I'm going to rewrite this now as integral sine x dx from 0 to pi all over 4 will be u times v. What is u? U is x. And v is x. So dv, this is dv. Here is dv. So u times v will be minus x cos x minus integral. What is u? U is minus cos x. Then multiply by dx. dx is dv. So this is dv. dv is dx. So multiply by dx. That's what we are going to get when we integrate. Of course, when we integrate here, we can see that 0 pi all over 4. So at the end of the day, we have minus x cos x minus, when we integrate cos, when we integrate sine, it's minus cos. When we now integrate cos, it will be sine. When we integrate cos, we are going to get sine. When we integrate sign, is minus cos. When we integrate cos, we are going to have sign. So if I go ahead and integrate, minus times minus is plus. If I integrate cos x dx, I'm going to have sine x. I'm going to have sine x. This will be the final one here. So if I integrate this, I'm going to have 0 to pi all over 4. That's what I'm going to get. Then I'll come back and substitute the 0 pi all over 4 over everything. So here, we are going to substitute when x equal to pi all over 4, then minus when x equal to 0. I'm going to have pi all over 4 cos pi all over 4 plus sine pi all over 4 minus, this is the first one. I go to the lower limit. What do I have there? Of course, when x equal to 0, everything here will be 0. Minus sine 0. Sine 0 is also 0. Everything here will be 0. That's what I'm going to get. Pi all over 4. You know, pi is in radian. Pi all over 4 is same thing as 45 degrees. So if I do that, I'm going to get minus pi all over 4 multiplied by cos pi all over 4 is 45. Cos 45 is 1 all over root 2. Cos 45 is 1 over root 2. And the same thing as sine 45. This will be multiplied by 1 all over root 2 plus sine, same thing as 1 over root 2. That's what you get. Then at the end of the day, we can have this to be, I can write this to be 1 all over root 2, square root of 2 minus square pi all over 4 root 2. So I may try to take the LCM as 4 root 2. Then this in this, we have 4 minus pi. And that will be the final answer. So the final answer, this will give us the final answer. And that is what you are going to have. So I would love to stop here because of our time. If you have further questions on the integration by part, you can just write at the comment section. I promise to provide solution to any given question. Thank you. And God bless you.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.